Mark from Mars TV. Welcome to Red Planet Project. On this channel, we talk about space, planets, and the future of exploration beyond Earth. In previous episodes, we explored Mars, asked how humans might survive beyond our home planet, and what would need to change for us to truly become a spacefaring species. Today, we're talking about a planet that breaks almost every rule we associate with planetary motion and seasons. A planet that quite literally spins differently than the rest of the solar system. This is Uranus. Imagine Earth suddenly stopping its upright rotation, tilting onto its side and rolling through space like a barrel. The poles stop being poles. The equator loses its meaning. On Uranus, this isn't a thought experiment. It's everyday reality. The planet's axis of rotation is tilted almost completely, creating extreme seasons on a scale we never experience on Earth. One hemisphere spends many years in near constant daylight, while the other is plunged into almost continuous darkness. These aren't months. These are entire decades of light, followed by decades of night. It's worth pausing here, because for many years Uranus was considered a calm and boring planet, a smooth sphere with little going on. Today we know that was an illusion. As its seasons change, Uranus's atmosphere becomes noticeably more active. Storms appear, bright cloud structures form, and powerful winds sweep across the planet. Wind speeds can reach several hundred kilometers per hour. This is not a dead world. It's a planet that simply changes very slowly, on a timescale we're not used to observing. A single season on Uranus lasts more than 20 Earth years. That means we've only observed the planet during a very short snapshot of its climate. It's a bit like trying to understand Earth's weather by watching it for just a few days. No wonder Uranus seemed quiet for so long. We were simply looking at the wrong moment. Naturally, the question arises, how did this happen? The most common explanation points to a massive collision early in the solar system's history, an impact with an object large enough to tip the entire planet over. It's a plausible hypothesis, but we have to be honest. We don't have complete certainty. Uranus doesn't give up its secrets easily, and that's exactly what makes it so fascinating. It's a planet that offers more questions than answers. If Uranus's extreme axial tilt were its only odd feature, we might have moved on long ago. But that's just the beginning. Let's look at its magnetic field. On Earth, the magnetic field is relatively orderly and closely aligned with the planet's rotation axis. It forms a protective shield against cosmic radiation. On Uranus, that logic breaks down. The magnetic field is strongly tilted and offset from the planet's center. As a result, the magnetosphere constantly changes shape as Uranus rotates, sometimes appearing stable, sometimes behaving chaotically. It's an environment that still challenges scientists trying to describe it with simple models. For many years, we thought Uranus was even stranger than it really is. That's because the only spacecraft to pass close to the planet did so at a very unusual moment. Solar wind conditions were extreme at the time. Only years later, after reanalyzing the data, did scientists realize we may have observed Uranus under conditions that weren't representative. It's a bit like judging an entire person's life based on one exceptionally bad day. Another mystery involves heat. Jupiter and Saturn emit enormous amounts of internal energy. For a long time, Uranus appeared to have almost none, as if it had cooled much faster than expected. Today we know Uranus does emit internal heat, but far less than the other giant planets. That raises new questions about its interior, how its layers are structured, how matter and energy move within it, and whether this unusual interior is connected to its strange magnetic field. Even Uranus's color can be misleading. Its distinctive blue-green appearance comes from methane in the atmosphere, which absorbs red light. To our eyes, the planet looks smooth and uniform. But beneath that appearance lie complex processes, multiple cloud layers, temperature variations, and atmospheric motions that are still poorly understood. Uranus looks simpler than it truly is. Now let's turn to something that often gets overlooked. Uranus has rings and moons, icy, fractured, distorted worlds that don't look like calm, inactive bodies. Some show signs of processes that may have occurred in the past, possibly short-lived heating, possibly internal activity. This suggests that the Uranian system may once have been far more dynamic than it appears today. The best example is Miranda, a small moon that looks as if it was once shattered and then reassembled in a completely random order. Massive cliffs, deep faults, and structures that shouldn't exist on such a small body. This points to a violent past, perhaps collisions, perhaps temporary internal heating. Miranda shows that the strangeness of Uranus doesn't end with the planet itself. And this brings us to a key problem. Uranus is one of the largest planets in the solar system. It orbits the same sun as Earth, and yet we've had only one close encounter. 1. No orbiter. No long-term observations. That means much of what we think we know is based on very limited data. In reality, we're still studying this planet from a distance. Why does all of this matter? Because Uranus isn't just a cosmic curiosity. It represents an entire class of ice giant planets that appear frequently in other planetary systems. The paradox is that we've discovered hundreds of similar planets around other stars, yet we still don't fully understand the one that orbits our own sun. Uranus is a key to understanding a large part of the universe. Uranus teaches us something important. The cosmos doesn't follow simple rules. Planets can evolve in ways we don't expect. And sometimes it's the least obvious worlds that tell us the most about how the universe really works. If you enjoyed this video, leave a like and subscribe so you don't miss future episodes. And if there's a planet you'd like to hear about next, let us know in the comments. Thanks for watching, and I'll see you in the next episode of Red Planet Project.